Hi students, welcome once again to the Om Institute YouTube channel, and in this video we are going to discuss the solutions of the ISRO 2025 Electronics SC paper. Okay, and the subjects that I am going to cover in this particular video include the combination of signal and system control systems and engineering mathematics. So let's get started and let's see how the questions were, what was the level of the questions. As expected, ISRO mostly easier questions only. Okay, so that we shall see how easy, or if there are one or two good questions also, you'll come to know here. Okay, so let's get started here. Okay, starting with control systems here, the subject is mentioned alongside. Now consider the system with the transfer function hs, s plus 1 upon s square plus 2s plus 2. Which of the following best describes the nature of the pole? Array, what is this? Okay, if you calculate the poles, okay, denominator, if I put it equal to 0, what are you going to get? Minus 2 plus minus root over of b square. Okay, minus 4ac, 4ac will become 8 divided by 2a. On simplifying, you will get it as minus 2 by 2 minus 1 plus minus under root of minus 1 is under root of minus 4 is j2, 2 again cancel. Minus 1 plus minus j, complex conjugate with negative real part. Option number C it is. Okay, simple. Okay, yeah, next one. The characteristic equation of a system is given to you. A fourth order system is given. Determine the range of the values of k for which a system is stable according to the Routh-Hurwitz criterion. Okay, simple only. Okay, you just have to feed this into the Routh array. Okay, let me feed it here, starting with the first two rows, s power 4 and s power 3. Okay, s power 4 and s power 3. What is their s power 4 coefficient? 1 and 3 and k. I will feed here 1 and 3 and k. Rest will be 2 and 4. 2 and 4 and 0. Okay, s square. Okay, 6 minus 4, 2, 2 by 2, 1. 2k by 2, because this is 0, so 2k by 2 is k, 0. So s power 2 Rondon, s power 1, 4 minus 2k. Divide by 1. Okay, not required. This is 0 because next column anyways is 0 on the top. Last entry of a row anyways 0. Coming to the s power 0 row. X into k by x, only k will be left. Again 0 because the next column 0, last column anyway 0. Now you want the system to be stable. That means no ROZ. Okay, and no sign change in first column. That is what you want. Okay, we want the system to be stable. Okay, so that means there are two conditions, no sign change in the first column and no ROZ, because if the system has row of 0, it may be marginally stable or unstable as well. Okay, but it cannot be purely stable. So what I want, no sign change and no row of 0 means if I started with plus, all should be plus. All should be plus means this k also should be plus, and 4 minus tk should be positive. This will tell you k less than 2. Okay, so the complete range of k greater than 0 but less than 2. So k is between 0 to 2. Okay, that is what it is. K between 0 to 2, option number D. Okay, I think this is not seen here, but okay, it is between 0 to 2. Right, all range starts from 0. Okay, what is the next question? I'll start here. Okay, the general form of lead or lag compensator. Okay, the general form of a lead or a lag compensator, and the basic general form of lead or lag compensator is a pole and a zero term. Okay, the only difference is lead compensator means zero dominant, lag compensator means pole dominant. Okay, so a simple zero and a simple pole term is there in the option number C. Okay, 1 plus ST1 divided by 1 plus ST2. Now, this also has a pole and zero term, but I'm talking about the standard form. Okay, the standard time constant form. Okay, because if you rearrange this, I'm just talking about the standard form, the general form. Okay, so the C is what is the option to be chosen rather than any other thing. Okay, rather than any other thing, because again this will introduce one more pole, this will introduce one more zero. So, okay, one simple pole and one simple zero. Okay, next one. Consider the following statements. A proportional plus derivative controller. So this question is asking you some information on the PD controller. Okay, some information on the PD controller. What it is? Okay, it has high sensitivity. See, sensitivity to what they have not mentioned, but yeah, one basic thing that we know about PD controller, important point is it improves the bandwidth of the system. Okay, by PD controller, we know that the bandwidth of the system increases, rise time decreases, bandwidth of the system increases. Bandwidth increases means effect of noise, sensitivity to noise. Okay, so as high sensitivity would be with reference to noise here. Okay, so that is correct. It improves the steady state accuracy. To improve the steady state accuracy, it should lower the steady state error. Okay, now Generally, proportional part is this effect, but PD controller is not meant for this. If your only target is to improve accuracy, that is by decreasing the error, proportional controller or PI controller. Okay, to be honest, PD controller is not for steady state error. Of course, although in the PD controller, the P part still, okay, the P part still, will rather decrease the error only, but the PD controller, one of the general effect is not counted as the accuracy or the error case, so we will not consider this. It increases the stability. Yes, that is one of the most important, effect of PD controller. It increases the stability of the system. Why? Because it introduces LHP pole. Okay, or you can, if you do the root locus analysis, you can say that it is going to make the root locus shift towards LHP, and hence the system is more stable. So 1 and 3 correct. Option number D you can choose here. Okay, 1 and 3, option number D. Okay, next question here. Now consider the system shown below. Okay, closed loop system is shown. The sensitivity of what? Of the steady state error for step input. Okay, with respect to U. Okay, now see, U is some parameter in the feedback path gain. Okay, and the gain of any block, forward or path, forward or feedback, ideally will not have input inside the gain. Input is applied to the system to produce some output. Okay, what is this parameter? Transfer function or the gain of the system. So I think what they wanted to mention in the question is calculate the steady state error for step input, and what is the sensitivity of that error with respect to U. With respect to U. Okay, okay. So yeah, let's do it. Let's do it in whatever given. But yeah, non-unity feedback. Number 1, it is non-unity feedback. So what do we do for non-unity feedback? Number 1, for error, okay, what do we do for non-unity feedback? For non-unity feedback, we will, either to convert to unity feedback system or go by the transfer function directly. Okay, or go by the transfer function directly. That is what is suggested. Okay, so non-unity feedback case is given. Okay, method number 1. What is the method number 1? Convert into unity feedback. And method number 2, okay, solve by the transfer function. Okay, rather than converting to unity feedback and using the forward path gain, solve by transfer function. How we can solve by the transfer function? Okay, let us see here from the second perspective only. Okay, so now what is the steady state error? Steady state error is given by limit s tending to 0, s into es. Okay, it is a steady state value of error signal, okay, which is given by final value theorem, limit s tending to 0, s into cs. This is limit s tending to 0, s into cs, s into es, and error signal is r minus c, the standard definition. Okay, r means input and c means output. Or further we can write down this as limit of s tending to 0, s into r minus what is the output? Input into gain of the system, where t means the transfer function or the gain of the system, correct? Overall gain, the closed loop gain of the system. Okay, so this steady state error now becomes limit of s tending to 0, s into r will be common and 1 minus t. Now let me solve and get the answer. Okay, let me substitute, let me solve and get the answer. So what it is going to be, this is limit, let me take it here. This is going to be limit s tending to 0, s into rs, rs step input. Okay, rs is step input. Okay, they have mentioned error due to step input. So step input Laplace transform 1 by s, then 1 minus closed loop gain. Okay, what is going to be the closed loop gain? G upon 1 plus GSHS, that anyways we know, k upon s, s plus 1, s plus 4, whole divided by 1 plus GSHS. That you can find separately in feed or I am just directly writing here, s plus u. Now, this s and s, the step and this one, this is cancelled. So what is left is limit s tending to 0, 1 minus of. Now finally solving the transfer function, what I am getting is multiplying by s, s plus 1, s plus 4. So k upon s, s plus 1, s plus 4 plus of k, s plus u. This much will be left. Now I am going to put s tending to 0, 1 minus, now s tending to 0, k upon this entire term 0 multiplied by 0 divided by k into u. So k cancel, 1 minus 1 by u. Yeah, that is the error, 1 minus 1 by u. But I now want the sensitivity of this error. Okay, I want the sensitivity of the error. Steady state error is 1 minus 1 by u, or let me write it this way, u minus 1 by u, which is definitely dependent on u. So how sensitive it is to this parameter u. Okay, so sensitivity. Okay, let us say this is some parameter x, which is steady state error. Now sensitivity of x with respect to u, okay, percentage change in x upon percentage change in u are finally given by the formula, sensitivity formula, u by x del x by del u. Okay, u by x del x by del u. Okay, this is a sensitivity formula. So u upon x, what is this x? U minus 1 by u into del x by del u, the derivative of this. So derivative, let's use this form only because 1 is constant, minus 1 by u derivative plus 1 by u square. So this u cancelled with above also, 1 upon all the u's cancelled, and this u minus 1 is left. 1 upon u minus 1, that can be taken as the answer. 1 upon u minus 1, and that is option number D for you. That is option number D for you. That's it. Okay, that is what is the answer to the question. Okay, so this one little bit time taking, just calculating the transfer function, feeding into the error, and then calculating the sensitivity. Okay, I mean not very lengthy, but as per the time we have in ISRO, this is little time taking. The previous ones are very straightforward, as you know. Okay, Bode plot, easy one only. Bode plot, easy one only. The following Bode plot is given. The transfer function of the system shall be how much? Now look into this. Okay, look into this much. Okay, initial slope minus 20. Okay, initial slope is given by what? For what formula? Initial slope minus 20n. If the slope is negative, minus 20n, and is minus 20, so n is equal to what? What is this n? Pole at origin. What is this n? Pole at origin. So n equal to 1 pole at origin. That is why all the options have a pole at origin, a s term in the denominator. Now, there is this corner frequency at 1. Okay, slope from minus 20 becomes minus 40. So there is a pole. Slope decreases means pole. Decrease by 20 means single pole. Single pole at the corner frequency of 1. Okay, then now from minus 40, as you're able to see the last section, the slope becomes minus 60 here. Okay, this is another corner frequency. Okay, and because slope again decreases, so this is also a pole term only. There is another pole at corner frequency of 20. Okay, corner frequency of 20. Right. Okay, of course, minimum phase system would be taken. Okay, so S plus 1, S plus 20. Okay, gain 2000. How it is, that also I'll show you, but option has to be anyways D. Okay, how this gain factor, if you have to write down the gain factor, so you must use the initial part formula. Okay, I always suggest the initial part formula. Poles at origin are there. Initial part formula, I write it as minus 20 n log omega plus 20 log k. Okay, what do I mean by initial part? Initial part means from the beginning, starting from the initial up to the first corner frequency. Okay, before first corner frequency, the part I call it as initial part. Okay, this one from here to here. So that is, now let's use this magnitude. You are able to see that at omega 1 magnitude of 40 is given. At omega 1 magnitude of 40 is given. Okay, so magnitude equal to 40 is minus 20, and already we highlighted 1, so log of omega, omega 1, I'm using this point. Okay, at omega 1, okay, suppose this point I call it as A point. Okay, at the A point where omega is 1, magnitude is 40 shown to me, correct? That is what I'm using, plus 20 log k. Okay, so this is what is giving you 20 log k equal to 40. Log k is 2, so k will be 10 raised to the power 2, which is 100. And then the transfer function, okay, is k. Okay, that is the k of the standard form. Now, whatever k we use in the Bode plot initial plot formula is the k of the standard form. Standard form, time constant form for first order term. And the time constant corresponding to any pole is given by 1 upon corner frequency, because what we learn, corner frequency is reciprocal of the time constant, correct? Na? Okay, so 1 plus, ST, 1 plus S by 1, first corner frequency 1, another one, corner frequency 20, so time constant 1 by 20. Now that is why the 20 will get multiplied above, it becomes 2000, then this is S, this term can be written as S plus 1, this term will become S plus 20. 2000 by S, S plus 1, S plus 20. Okay, option number D it is. Done? All right. The frequency response of a system is given in the following table. Okay. What is the phase and the gain margin of the system? Okay, easy one only. Okay, because it's a basic definition if you know for phase and gain margin. Like, look into this. Okay, look into this frequency where the gain, okay, of the system. Now see, this is 100% an incorrect question. This gain is not, has to be in decibel. This is not in decibel. Make it very clear, because if it is in decibel, answers are not going to match for you. Okay, Because gain crossover frequency is the frequency where absolute magnitude is 1 or decibel magnitude has to be 0. So there is nowhere decibel magnitude 0. Okay. So decibel magnitude 1, absolute magnitude 1. So then this becomes omega g. Clear everybody? This would become the omega g. That is a frequency of 10. Okay. Phase margin is given by what formula? 180 degree plus angle gj omega g at j omega g. Okay. Angle gj omega g at j omega g. Phase as omega g. Okay. So what is the phase at omega g? Minus 155. Okay, so this answer is nothing but 25 degree. Okay, the phase margin is 25 degree. Okay, that is there. Now gain margin. Gain margin is calculated. Okay, phase margin was calculated at omega g, that I highlighted. Okay, now what is the gain margin calculation? Gain margin, okay, the absolute gain margin, decibel, not the decibel one, absolute one, is given by 20 log 1 upon mod gj omega p at j omega p. Okay, or you can write it as minus 20 log of mod gj omega p at j omega p. Okay, sorry, I've written it I've written the logarithm one. I wanted the absolute gain margin. Sorry. The absolute gain margin is 1 upon gain at omega p. Okay. 1 upon mod gj omega p at j omega p. Now see. What is omega p? Omega p is the frequency at which the phase of the system is minus 180 degree. Okay, now where is this? This is minus 180 degree. So this corresponding frequency is omega p, phase crossover frequency. What is the gain? 0.25. So 1 upon 0.25, and that is 4. Not in decibel. So this was an incorrect entry. Okay, so 25 and 4, option number B is to be chosen. 25 and 4, option number B. Done? Okay, next question. Okay, now see, signal and system. Okay, so these were the questions on control systems. Okay, all were almost easy only. Okay, I just told you sensitivity was little bit calculative, but okay. Now you see, one question from gain and phase margin. Okay, one question from Bode plot. All are very expected topic. Nyquist plots I didn't touch. Okay, so this was this second. Third is steady state error plus sensitivity. Okay, fourth, controller based conclusion. Okay, fifth also a basic compensator, just basic definition. Okay, then if I call it as 6, Rauterwitz, okay, range of K, very, very common question. Okay, and 7th one is nothing but a transfer function poles question, very easy. Okay, so almost everything is easy only. Total 7 questions were there from control system. Now going towards signals and systems. Okay, which of the following 3 signals given below is periodic? Okay, X1, X2, X3, or none of the above. Okay, so see, there have been some typo errors in the paper possibly, that you can understand. Okay, X20. Now see, this signal which is multiplied by UT is going to be aperiodic. Because when I say periodic means pure periodic, and for a signal to be periodic, it has to be periodic from minus infinite to infinite. Minus infinite to infinite. So because it has UT, we can call it as a switched periodic signal, okay, which is periodic for one side. Because if I remove the UT, na, e power j omega t with the phase shift doesn't matter. If it is pure e power jt or any e power j omega naught t, okay, in continuous time domain, it is periodic with period of 2 pi by omega. Okay, that is there. Okay, but UT will not make it pure periodic, and we can call it as switched periodic. Okay, periodic for one side. But okay, anyways, this will not be answer right now. Un plus u minus n. Now, it is a dt domain. Okay, if it was ct domain, ut plus u minus t is flat 1. Here, the result will be un plus u minus n equal to 1. Okay, for any n not equal to 0. But at origin, what happens? Okay, un is also 1, and when you mirror image it, the origin value remains as it is. So, u minus n, 1 plus 1, it is going to become 2. Okay, so it is 1 for all values of n. If this was also 1, I could have called it, okay, periodic. After every one value of time, the value repeats. Okay, but no. Okay, it is aperiodic right now because the value at origin is something else. Okay, these two signals are overlapping at n equal to 0. Okay, then x3t. Okay, so x3t here they have called it as t. So here also I should write it as t. That is one typo error. It has to be delta t minus 4k minus delta t minus 1 minus 4k. And also there is one more correction in the limit. If I assume the limit minus x to x, what is x not mentioned? Okay, there may be a signal only in this window based on the limit x. Okay, if it is only in this window, it cannot be periodic. Periodic means minus infinity to infinity. Okay, right. But the intent of the question is k equal to minus infinite to plus infinite. Okay, minus infinite to plus infinite is the intent of the question. Then if you draw this x3t signal, if a rough waveform I wanted to present for x3t, how it will look like from minus infinite to infinite, the k has to be okay. So starting with k0 means delta t. Okay, delta t means a impulse at origin. K0, there is one more term, delta t minus 1. Okay, so there is a impulse at origin, there is a impulse at t equal to 1. Okay, one positive going, one negative going. Okay, this is 0, this is 1. Now as soon as you put k equal to 1, you get delta t minus 4. So another impulse at t equal to 4. Okay, delta t minus 1 minus 4, delta t minus 5, impulse at t equal to 5, and again that is a minus, negative. I'll draw negative side. Okay. Then k equal to 2, delta t minus 8. Okay, delta t minus 8, t minus 1 minus 8, t minus 9, and that is negative impulse. Okay, this is 8, this is 9, etc. This is clearly periodic. K minus infinite to infinite, that is what, k may be negative. If you take k minus 1, okay, you will get this one. Okay, minus 4. Okay, delta t plus 4 is the impulse at minus 4, and then minus 1 minus 4. Okay, minus 1 plus 4, sorry, there will be delta t plus 3. Delta t plus 3 is the impulse at minus 3. Okay, so see, periodicity is there, na? Okay, how much is the period? If I ask you period, starting from origin, the next impulse, the next positive impulse is that time period as a time of 4. So the fundamental period is t equal to 4. This one is periodic. Okay, option number C. X3t is periodic. Option number C can be chosen as the correct answer. Okay, dear? X3t. Option number C. Okay, then let's move ahead. What is there? Which of the following system is not causal? Hn is given. Okay, now causal, for a system having some impulse response Hn to be causal, Hn must be 0 for n less than 0. It should not go to the left of origin. Okay, so impulse is at origin, causal. Unit step, n greater than equal to 0, causal. Okay, 0.5 power n un, anything multiplied by un will start from origin and go right. It cannot come to n less than 0. Del n plus 1. Del n is an impulse at origin. Del n plus 1 is a left shifted impulse, and that is available at n equal to minus 1. That means this signal Hn will be not equal to 0 for one value of n negative. Okay, so that makes the system non-causal. So which of this non-causal? Option number C. Okay, simple one. Okay, next. A discrete time LTI system has the impulse response del n plus del n minus 1. What is the output for the input un? Okay, output convolution, na? General way. What is the output? Say the output is yn, generally calculated as xn convolution hn, and hn contains only two impulses. Easy question. The input is unit step, convolution with what? Convolution with the hn. If I substitute that, del n plus del n minus 1. Those who know the correct property, it is an oral question. You don't have to write this in the exam, because you can say directly un convolution delta n is the first term going to come. Un convolution delta n will be un. Un convolution delta n is un. So delta n minus 1, un minus 1, time shift. Because any signal fn convolution with delta n, you will always get fn, replica property, identity property. Okay, if any signal is convoluted with impulse, okay, the answer will be the same signal fn. The same signal is replicated. Okay, so un convolution un is un convolution delta n is un convolution delta n minus 1, un minus 1. Any one signal shifted, output is also shifted. So my answer is option number A. That's what, if you know this property, you just have to look and you can tick mark the answer. No need to use any pen also here. For the following function, the poles and zeros will be, okay, the poles and zeros will be, okay, a simple Laplace, you just calculate Laplace and a pole zero function. Again, it could be signals, you can place it in controls also. These are like common question. Okay, so what is its Laplace transform? Let me calculate the Laplace transform here. Okay, the Laplace transform of this is going to be impulse Laplace transform 1 minus 4 by 3 e power minus t ut Laplace 1 upon s plus 1 plus 1 by 3 e power 2t Laplace 1 upon s minus 2. Okay, 1 upon s minus 2, right? E power plus 2t ut. Now just let us simplify this, or rather let me take the 1 by 3 first outside. Okay, so this will be 3, then minus 4 upon s plus 1 plus 1 upon s minus 2. Poles are very simple, minus 1 and 2. 0 also we have to calculate and say the answer. So 1 by 3, 3 s plus 1, multiplying throughout s plus 1 s minus 2, then minus 4, this will be s minus 2, and plus here what will be multiplied is s plus 1 whole divided by s plus 1 s minus 2. Okay, just have to simplify the numerator. Okay, multiplying this s is 3 s square, then minus 2s plus s minus s into, so this was 3s square, minus s into 3 minus 3s, minus 2 into 3 minus 6, then here minus 4s, minus 4 minus 2 plus 8 plus s plus 1 divided by s plus 1 s minus 2. Now see the numerator part, 3s square, okay. Then what else is there? Minus 7s plus s minus 6s, and then constant part, 8 plus 1 9 minus 6 3, constant part is 3, okay, divided by s plus 1 s minus 2. Okay, so if I continue here, now see, can you take the 3 common? Yes, and divide by the 3. So what is going to be the excess? 3 is cancelled, so s square. Okay, then 2 will be left here, 1 will be left here. S square minus 2s plus 1 upon s plus 1 s minus 2 upon s plus 1 s minus 2. Okay, now this is what? This is a minus b whole square. This is nothing but s minus 1 whole square by s plus 1 s minus 2. So what are the poles? 2 and minus 1. 0 is at 1. Repeated 0 at 1. Okay, now let's see the answer. Okay, pole at minus 1 and plus 2. Okay, pole at minus 1 and plus 2, and 0 is at plus 1. 0 is at plus 1. Option number B. Pole is at minus 1 and 2, and 0 is at plus 1. Correct. 0 is at plus 1. Option number B. It is repeated 0, but okay. Option number B is what that you can choose. Okay. Anyways, next question. Inverse of the Laplace transform. Okay, inverse Laplace transform. Okay, what is this? I'll factorize the denominator first of all. S square plus 5s plus 4, s plus 1, s plus 4. Okay, 1 plus 4 will give 5s, 1 into 4 will give you this 4. Okay, now I'll split it into partial fraction. How much? If I directly want to split it, because constant numerators, I'll directly try by subtraction. S plus 1 minus s plus 1, 1 upon s plus 1 minus 1 upon s plus 4. S and s cancelled. 4 minus 1, 3 will be left. I want 10, na? Okay, write it 10 by 3 then, because when you subtract these two, 3 is coming, the 3 will cancel, and I want the 10, that will be there. Okay, no problem, done it is. Okay, so what is the inverse Laplace transform now? If I take the inverse Laplace transform, 10 by 3 constant, 1 upon s plus 1 is for e power minus tut. Okay, e power minus tut. Next one, 1 upon s plus 4, e power minus 4 tut. Okay, ut they have not written, okay, assumed causality only. Okay, with the minus sign, in between minus is there, 10 by 3 e power minus t minus e power minus 4t. Option number D. Okay, option number D. Basic inverse Laplace question. Now signal xt equal to sine 100 pi t by pi t, ideal low pass filter. Okay, sine omega ct upon pi t, impulse response of ideal low pass filter. Okay, or you can understand this way, this xt is nothing but you can convert to sampling function. To convert to sampling function, you will multiply by 100 and also divide by 100. If you divide by 100, denominator becomes sine 100, denominator becomes 100 pi t. Okay, so sine theta by theta format will come, okay, which is sampling function. Okay, so xt is 100. Okay, sampling 100 pi t. Sampling 100 pi t function ranges from sampling 100 pi t function. The range of sampling 100, sampling 80 function, sampling theta function is from minus infinite to infinite. So it is not time limited. Okay, but it is band limited. Why? Because what is the Fourier transform of it? Okay, the Fourier transform of it, x omega, is given by, I'll write down the exact formula because Fourier transform of sampling is rect. Okay, for you it is a simple question. Sampling minus infinite to infinite. So time domain, it is, for infinite range, but sampling Fourier transform rect. Rect has a finite duration, band limited. Okay, so you can directly choose the answer. It is not time limited, but the band limited. That you can just see and decide. Okay, you can see and decide. But if you want the exact formula, answer is 100 pi by 100 pi rect of omega by twice of this 100 pi. Okay, and answer will be, okay, the ideal low pass filter frequency gain, rect 100 omega by 200 pi. You know what I have used? Remember this very important formula. Sampling 80, 100 was anyways constant. For sampling 80, the Fourier transform is pi by a rect of omega by 2a. A useful formula in the frequency domain discussion. Okay. Anyways, answer was C. Next question. Now see, in time domain rect is given. Okay, see what I have just written. Okay, there are, now if I come to rect t by t, I'll write down these two very important formula. In any competitive exam, directly, indirectly, around these questions are always there. Rect t by t, the Fourier transform is t sampling omega t by 2. Okay. And if it is sampling AT, what I have written previously, I'll mention here as well. Okay, the Fourier transform for sampling AT is given by pi by a rect of omega by 2a. These are Fourier transform pair related by duality also. Fourier transform pairs are dual in nature. Rect has the transform of sampling function has the transform of like rect function. Okay. So let xt is rect t by 2, where rect t by 2, okay, they have described the rectangular width. Okay, whenever I say rect t by t, it is a rectangle. Okay, it is a rectangle of width t minus t by 2 to plus t by 2. That is what they are describing. Rect t by 2, it is a rectangular pulse of width 2, correct? Okay, located minus 1 to 1. Centered at origin, we draw normally symmetrically only rectangular function. Okay, as per the rect definition. What is the Fourier transform x omega? Okay, what is their Fourier transform x omega? T sampling omega t by 2. T is 2, sampling omega into 2 by 2. The answer is 2 sampling omega. But sampling omega is not sync omega. Mathematically, the definitions are different. Okay, this is actually 2 sync. Now see, if you have to, in the exam time, if you have to complete and choose one answer, okay, you can choose it. Okay, it's a incorrect options are there, because that is, what we know. What is the sampling theta function? Sampling theta function is sine theta by theta. Okay, what is the sync theta function? Sync theta function is actually given by sine pi theta by pi theta. Okay, and they are related. Sampling, if you put down pi theta, here if you put down pi theta, then you get sine pi theta by pi theta, and that is equal to sync theta. Okay. So if you have to convert anything, okay, from sampling to sync domain, okay, what you have to do? Okay, sorry, I think I've written reverse. What you have to do? You can write it as 2 sampling omega by pi. That is what, na? Sampling pi theta is sync theta. Sync theta is sampling pi theta. Or what is sampling theta? Divide by pi here. Sync theta by pi, omega by pi. That is why I'm telling options are not correct here. Okay, it can be 2 sync omega by pi maybe, or 2 sync omega by pi. Any correction is required, but okay, if they have to match something, you can then match it as option number A. Maybe they have taken the answer as sampling omega. That's what is the clue that comes up. Okay, anyways, next one. What is the Nyquist rate for the continuous time signal? Okay, sinusoids are given. Okay, so what is the highest frequency component of the sinusoid? Okay, this is having the fundamental. Now, sinusoids, they are single tone components. Okay, when you see the spectrum, okay, only one frequency corresponding to the fundamental frequency will come up. Okay, so what is the omega naught for the first term? 100 pi. Okay, for the second sinusoid given, the omega naught is 200 pi. Okay, so what is the highest frequency component of the signal? Is at 200 pi. Nyquist rate, which talks about minimum value of omega s as per ideal sampling, and that is given by twice of omega m, and twice of omega m is 400 pi. Okay, this one is radian per second. Options are in hertz, so divide by 2 pi. 400 by pi 2 pi, and the answer is 200 hertz. 200 hertz. Answer is C. That's it. The answer is the C one. Okay, next one. Oh, sorry, B option, 200 hertz. Okay, next question. If a discrete time LTI system has the frequency response h e power j omega is 1 upon 1 minus 0.5 e power minus j omega, impulse response hn. Okay, one of the known DTFT pair a power n un, okay, has the DTFT of 1 upon 1 minus a e power minus j omega. Okay, or any symbol of omega you can use. So 1 upon 1 minus 0.5 e power minus j omega is the Fourier transform of 0.5 power n un. Okay, 0.5 power n un. Okay, also one more thing, they have given the data in terms of LTI system. This has a frequency response h e power j omega. What is the impulse response hn? The impulse response hn and the h e power j omega, or simply I call it as h omega, they are the DTFT pairs. The frequency response is the DTFT of the impulse response of the system, or vice versa. Okay, so answer anyways is A. Okay, next one. How simple it is. Z transform for shifted impulse delta n minus k. Okay, what is the answer for delta n is 1. So for delta n minus k, time shifting, okay, will bring z power minus n naught, z power minus k, option number B. Option number B. Now, signal questions are mostly formula based, as you see. Okay, now engineering mathematics question. Okay, engineering mathematics. Have a look into this one. Let A B belong to Rn cross n, that is n cross n matrices. Okay, be similar matrices. Okay, which of the following is true? Similar matrices, yes, they have the same trace, they have the same determinant, they have the same eigenvalues. That too with the same geometric multiplicity, same algebraic multiplicity, same characteristic equation. Okay, and also they have the same rank as well. Okay, so in point of what I told you, determinant, trace, same eigenvalue with same characteristic equation or characteristic polynomial, all of the options are correct here. Okay, a fundamental question on the knowledge of similar matrices. Okay, which we normally study for similarity transformation. Okay, anyways, next one. Customer arrival at a bank follows a Poisson process with the mean 10 per hour. Okay, what is the probability that the time between two arrivals is greater than 10 minutes? Now see, the question, the Poisson process is mean 10 per hour, number of customers. Now see, okay, if I talk about number of customers, okay, this follows Poisson. Okay, having a lambda equal to 10 per hour, having a lambda of 10 per hour. And the question is not on number of customer, question is arrival between two. What is the probability that the time between two arrivals is greater than 10 minutes? Okay, okay, that minutes we'll convert to hours, that is okay. But, okay, from a Poisson process, whenever you try to measure the time between arrival of two samples is modeled by exponential distribution. Okay, for Poisson process, time between arrivals. Okay, what is the probability that between two arrivals, the time between two arrivals is greater than this? Okay, so time between arrivals, okay, it will follow exponential law. This will follow exponential distribution. Okay, so the question is, now in any exponential distribution, if t is exponential, probability t greater than t. Now, okay, because the question is greater than something. Okay, in any exponential distribution, one of the known formula that you know is, okay, one of the known formula that normally you might have seen this way, probability x greater than a is e power minus lambda a. Okay, probability t greater than t is e raised to the power minus lambda t. Okay, is e power minus lambda t. Okay, now the question is, what is the probability that the time greater than, now see, this lambda is in hour, so if I convert this 10 minutes, it becomes 10 by 60 hour in terms of hour. If I want to convert, so that is 1/6 of a hour. So what I want, t greater than 1 by 6, so that will be e raised to the power minus lambda. Lambda is 10, t is 1 by 6, so e power minus 10 by 6. That is what it is. Calculation they have done for yourself. They wanted this expression. Option number A, e power minus 10 by 6. Okay, e power minus 10 by 6. Option number A it is. Anyways, next one. Which distribution is memoryless? Now, what is the concept behind this memoryless? Okay, memoryless means probability that, suppose you calculated x greater than x, okay, or if you confuse with the small letter x, let's say you calculated probability k less than k, okay, and then you are calculating probability x greater than k, you calculated probability x greater than k plus h, something of that kind, okay. A system will be memoryless, okay, the system will be memoryless if the probability x greater than k plus h, given that x greater than k, okay, given that, okay, you know this probability x greater than k, okay, the probability x greater than k plus h is independent of it, Okay, now what does it mean? Let me first write down both of these expressions. Okay, this is the condition I have written. If what happens, okay, I'll tell you. Okay, let me write down these two calculations first separately. Okay, normally exponential law follows this. So if I just explain you with respect to exponential PDF, okay, or not for PDF, for exponential law, again using the same thing that I told you. Okay, probability x greater than a is e power minus lambda a, correct? So probability x greater than, suppose k is the word I have used, this will be e power minus lambda into k. Probability x is greater than k plus h. will be e power minus lambda into k plus h. Now, right side, let me use this conditional probability P of A by B. P of A by B is given by the formula P of A intersection B divided by PB. Okay, this is like the formula P of A by B. Okay, P of A by B. P of A by B is given by the formula P of A intersection B is divided by PB. Now, this means that probability A intersection B. Now, when I take the intersection of these two, x is greater than k plus h. Okay, intersection x is greater than k. Okay, it has to be greater than greater number divided by PB. PB means this event, probability x greater than k. Okay, intersection means greater than the greater number, x greater than k plus h. So it has to be greater than k plus h. So this becomes probability x greater than k plus h. Denominator probability x greater than k. Now, if I substitute the formula, the numerator formula will be e power minus lambda. Okay, I'll split the form e power minus lambda k, e power minus lambda h. Upon denominator probability is e power minus lambda k. These two will get cancelled. Answer is e power minus lambda h. Now, what is e power minus lambda h? Alone is probability x greater than h. Okay. So, what I was trying to tell you that if condition, what is memoryless? The system, the distribution is memoryless if probability x greater than k plus h. Given that probability, given x greater than k is equal to probability x greater than h. Now, what does it mean? Okay. You are given that x is greater than k, and then you are trying to find the probability x is greater than k plus h. Okay, and the final answer is independent of k. The final answer only depends on h. That means how much ahead of k. Initially, you know, understand with the value. Suppose if I tell you what is the probability x greater than 1, and here if I ask you what is the probability x greater than 3, answer will be probability x greater than 2. Already, okay, if you know what is probability x greater than 1, only the extra 2 you have to calculate additionally. It will not, okay, require the probability up to that one. That is what memoryless is. That is what memoryless is. Okay. Okay. So exponential follows this memoryless case. Exponential follow the memoryless case. Okay. Next one. Exponential, which is analog in continuous distribution, which is analogous to the geometric distribution in discrete random variable. Okay. Okay, a partial differential equation question. What is the solution of the below partial differential equation? Del u by del t equal to 4 del 2 u by del x square, u0 t equal to u pi t equal to 0, u of x comma 0 equal to sine 3x. U of x comma 0 is sine 3x. Okay, now very clear. Okay, first I'll tell you the logical way of solving it. If you say that u of x comma 0 is sine 3x, okay, that means when I put t equal to 0, answer should be sine 3x. If I put t equal to 0, all e power 0 will be 1. But if you put e power 0, then how minus sine 3x will come? So B and D, C are not possible. It has to be plus sign. Okay, that means A or D. Okay, so this clearly hints you that the answer has to be A or D. Okay, now any further input that I can get from here? Okay, now that we have to actually calculate only. Okay, now see, from A or D, let us say that, okay, now method number one. Okay, as per A or D option, we can say that let the u function is equal to, only difference is the exponential power. Na? Suppose it is e power minus kt sine 3x. Sine 3x is anyways common. Na? Sine 3x is anyways common. Okay. Sine 3x is anyways common. Now see, what is del u by del t? What is del u by del t? When you differentiate with time, you will get minus k e power minus kt, and x will be constant. You have partially differentiated. Okay, and this function is again u, so you can write down this as minus ku. But now del 2u by del x square required. No? So what is del u by del x? Number one time. Okay, if you differentiate sign, you will get cos. Okay, so 3 e power minus kt cos 3x. Because of chain rule, the 3x derivative 3 is written here. Now double derivative del 2u by del x square. Again, because of chain rule, 3x derivative, another 3 will come, 9 will come, but cos derivative minus sign. So minus 9 e power minus kt sine 3x. Okay, now this becomes how much? This is minus 9u. Okay, the other part is u only, no? The minus 9u. Now the given differential equation, the given partial differential equation is nothing but del u by del t. Okay, del u by del t, which is how much? Minus ku is equal to 4 times, okay, is equal to 4 times into minus 9u. Okay, this has to satisfy, and hence you can find the value of k. This has to satisfy, and you can find the value of k as 36. You can find the value of k as 36. equal to 4 del 2u by del x square. Correct? Huh? This is sine 3x given. Okay, so if you satisfy here, 4 was there and 9 came up there because of 3 into 3 when I differentiated with x. Okay, so 36. Okay, now what is the method number 2 I am trying to tell you now? What is the method number 2? The way of calculating this partial differential equation. How do you actually solve this? Okay, now if you try to solve it by variable separable. Okay, now let's say u is equal to, now u is a function of x and t, na? U is a function of x and t. Okay, and suppose it is broken as two separate function. One is a function of x, one is a function of time. Okay, one is a function of x, one is a function of time, assuming variable separable. Okay, then what is del u by del t? Del u by del t means this x function will be constant. Let me only write this way, capital X into capital T. Okay, only the t function derivative will come. And what is del 2u by del x square? Okay, now when you're differentiating with x, first you will write down x dash t, first derivative. Again you differentiate, again t will be constant. Only x dash derivative, x double dash will come. Now, if I feed this in the equation, del u by del t is equal to 4 del 2u by del x square. What is del u by del t? Okay, x t dash is equal to 4 x double dash t. Okay, or you can split the variables now. T dash by t is equal to 4 x double dash by x. Now, because answer is in sign form, I am taking it as minus k square. Suppose this is equal to some variable minus k square. Both of them are equal. T dash by t equal to 4 x double dash by x equal to minus k square by 4. Okay. So, what is the first one? T dash equal to minus k square t. Okay. Or bringing the t on the left side. What is t dash? Del t by del t plus k square t equal to 0. When you write down the auxiliary equation for this, linear equation it will be first derivative m, then plus k square equal to 0. So, what is the value of m is minus k square. Okay, the m will be minus k square. Okay, then, so what is the t function? Okay, it can be written as some constant c e power minus mx or minus e power mt. Okay, e power mt, it's a function of time. So, c e power minus k square t. The second one will be 4x double dash equal to minus k square x, bringing the x on the left side. So, you have 4 x double dash plus k square x equal to 0. Auxiliary equation for this will correspond to 4m square plus k square equal to 0. So, m square will be like minus k square by 4, or m will be plus minus j under root of minus 1, and then under root of k square by 4, I'll write k by 2. Okay, where the roots are coming up as alpha plus minus j beta. Alpha plus minus j beta. Okay, so alpha plus minus j beta means, okay, what is going to be the solution here? The x function, x as a function of x. Okay, we write down the answer, e power alpha x, c1 cos beta x plus c2 sin beta x. That is what we can use here. Okay, so x function will be, now what is alpha? Alpha is 0. E power 0 will be 1. So only c1 cos beta x. Beta will be k by 2. Okay, so c1 cos k by 2x plus c2 sin of k by 2x. Done. So what is the u function overall then? The u function overall, which was the product of x and t, or t and x, what was the t function? Is some constant c e power minus k square t, c e power minus k square t whole multiplied by c1 cos k by 2x plus c2 sin of k by 2x. This is how I have arranged. Okay, now what are some initial conditions given? Okay, what is the first initial condition given to me is, let's use this, u of 0 t equal to 0. U of 0 comma t equal to 0. That means if I put x 0, answer should be 0. Okay, c e power minus k square t, t is t only. If I put x 0, okay, so cos 0 is 1, c1 into 1 plus c2 into 0 is equal to 0. Sin 0 is 0. So what I am getting is c e power minus k square t into c1 equal to 0. This means that the constant c1 has to be 0. C cannot be 0. If c is 0, the overall answer becomes 0. No. Okay, so c1 is 0. Now, if c1 is 0, then you can write down till here. What is the u of x comma t will only be c2 gone. So, will only be c into c1 e power minus k square t cos of k by 2x, something like that. C into c1 e power minus k square t cos k by 2x. Okay. No. C1 is 0, na? Sorry. So C1 is 0, so the other part is left. Okay. Sorry. Sin k by 2x, and this will be C2. C1 was 0, C2 is left. Sin k by 2x. Now further dear, in this if you put the next condition is also given as u of pi comma t is also 0. U of pi comma t is 0. Now that means when you put x equal to pi, okay, so C2 e power minus k square t sin of k by 2x. Okay, or rather if I first use the other condition, then it will be better. What is that other condition is ux comma 0 is sin 3x. That will match here, na? U of x comma 0 is sin of 3x. So now when I put t equal to 0, see what will I get? C2 e power 0 1. Okay, e power 0 1 sin of k by 2x is going to be how much? Okay, is going to be how much? Is going to be given as sin 3x. Okay, so see, what do I get? C into C2, if you compare these coefficients, C into C2 has to be 1, and secondly, C into C2 has to be 1, and secondly, k by 2 is equal to 3. Okay, so k equal to 6. K equal to 6. Okay, so now k and C2 both obtained, so that other condition not required. Final answer then, okay, final answer then I am writing here u of x comma t. Now see, C into C2 is 1, e power minus k square, now k is 6, so k square 36, e power minus 36 sin k by 2 x, which is sin 3x, e power minus 36t sin 3x, k 36 here also I told you. Okay, just I added up because you know how to generally solve it. That is what I have explained you here in this partial differential equation. Okay, the variable separable basic case. Okay, fine. Okay, anyways, let's move ahead. Okay. Yeah, so these were the questions, total of 21 from you know, the control, signals and maths, 7 from control, 4 from maths and 10 from signals. Okay, I repeat, 4 from maths, 7 from controls and 10 from signals. Okay, almost easy. Yeah, maths was little better as compared, if you think with respect to other subjects like control and signals, they were pretty much easy. Maths was little better. Okay, but only less weightage, and always for ECEE in ISRO maths expected less weightage. Okay, now guys, if you're you know, targeting the AE examination, because you know huge vacancies are expected in AP and Telangana. Okay, so for Genco, Transco, Discoms, for both AP and Telangana, online live course have been launched on the OM Institute. Okay, on our app. Okay, so the batch starts from November 5th. Okay, yes guys, so the new batch starts from November 5th. The validity of the course will be 1 year, and the fee will be 24,999. And for any of the OM old student, if you have taken any of the OM course, you know, whether live course or offline course, any of the OM course earlier, you get a flat 30% discount. Okay, these are some important updates. And if you are, you know, also looking, you know, in case looking for offline classes for the AE or AEE examination, okay, so for the both AP and Telangana, Transco and Discoms, the new offline batch starts November 10th. Okay, for any more queries, you can contact our support numbers 95156 94043 and 94053 and get all your doubts rectified. Okay guys, for gate 26, if you are preparing and if you still want you know, to learn through the India's ECEE best faculty team, you can opt for the online live course. No more offline courses for gate 26 because the time is very less, but you know, the online live course you can still go. Okay, for gate 26, 1 year validity, fee is 19,999, or if you're targeting gate 27, okay, then you can opt for 2 year course. The fee is 28,999 for 2 years validity for gate 27. Of course, for gate 27, offline batches will also be announced in the upcoming time. Okay, yeah, that's it. Thank you. And yeah, for any more doubts or connections with me, you can also be connected in my Telegram handle, the link being mentioned here. Okay, that's it. This is Rakesh Talreja signing off. And if you want more such useful videos on GATE, engineering services, ISRO, AE, AEE, any of the preparation, okay, stay connected, because a lot of preparation guidance video, previous year question sessions, these solutions videos will be there on OM Institute YouTube channel. So if you have not subscribed, do not forget to subscribe the channel immediately. Thank you.